Okay, this one, they're giving us areas. They want to know what the scale factor is for perimeters. Okay, so if we are given a area scale factor of 4 to 16, that simplifies down to a 1 to 4 scale factor. Remember, that is the length scale factor squared. So we need to square root it for the length scale factor. What do we get? We get a square root of 1 is 1, square root of 2 is 2. Okay, and the ratio of the perimeters, that is the scale factor and the ratio of perimeters is what we get for an answer there. So it's a 1 to 2. And if we look on our answer page, um, you see that it's the same for both of them. 1 to 2, 1 to 2, because the scale factor is going to be what the perimeter ratios are. So for all of these, they're going to be the same. So I'm just listing it once. Okay, two trapezoids with areas of 49 and 9. So if we're given areas of, if we give a scale factor for the areas of 49 and 9, they can't be simplified. There's nothing to divide them by. So now you just go straight away to square rooting them to 7 to 3, which is the scale factor for lengths, given that scale factor for areas, 7 to 3. And of course, the scale factor and the ratio of perimeters are the same. So you'd get 7 to 3 and 7 to 3 twice, right? You get that twice. Now, two equilateral triangles have areas of 16 root 3 and root 3. So how do we write that? Well, if we had a 16 root 3 to 1 root 3, let's first divide them both by root 3 and get a 16 to 1 ratio. That's the area ratio, and so we need to square root it for the length ratio. The square root of 16 is 4, square root of 1 is 1. That's the scale factor, and the ratio of the perimeters is going to be exactly the same as the scale factor because it's a measure of length, 4 to 1 as well.